Good morning, afternoon, evening, or night, depending on whenever you're watching this. I'm Max Chitwood, and this is my oral compendium on Noam Chomsky. I'd like to start this out with a brief anecdote as to my first experience learning about Noam Chomsky. When I was in high school, I played football, unfortunately, and our line coach, every time he thought we were not hitting good in practice, would tell us. He was going on like a 20-second long diatribe about how Noam Chomsky is a great linguistic and academic, but you don't want to hit like him, which was just kind of bizarre, I guess. Anyways, that was my first experience. On to the actual content. Noam Chomsky is one of the most influential intellectuals of the 20th and 21st centuries, with profound impact across multiple disciplines, including linguistics, philosophy, cognitive science, and even computer science. To a broad CS audience, Chomsky's work provides foundational insights that bridge human language and computational systems, making his contributions indispensable for understanding areas such as formal language theory, automata, and natural language processing. Who is Noam Chomsky? Noam Chomsky is often referred to as the father of modern linguistics. He revolutionized the field with his theory of generative grammar, which posits that humans possess an innate ability to produce and understand an infinite number of sentences using a finite set of grammatical rules. This theory is grounded in his famous Chomsky hierarchy, a classification of formal grammars that has become a cornerstone in theoretical computer science. Beyond linguistics, Chomsky is an influential political commentator and cognitive scientist with a career that spans over 7 decades. Born in 1928, Chomsky began his academic journey at the University of Pennsylvania, where he developed his groundbreaking ideas. His seminal work, Syntactic Structures, 1957, laid the groundwork for a scientific approach to studying language, emphasizing the mathematical underpinnings of syntax and grammar. These ideas quickly transcended linguistics, influencing fields like artificial intelligence, machine learning, and computer architecture. The Chomsky hierarchy is a classification of formal languages into four categories: regular languages, context free languages, context sensitive languages, and recursively enumerable languages. Each level of the hierarchy corresponds to a class of computational machines. Regular languages are recognized by finite automata, context free languages align with pushdown automata, context sensitive languages are processed by linearly bound automata, recursively enumerable languages require Turing machines. This framework is pivotal in understanding computational systems as it defines the computational power required to process different classes of problems. For example, regular expressions in programming rely on the principles of regular languages, while compilers often leverage context free grammars. Connections to computer science and architecture. Generative grammar and formal language theory. Chomsky introduced the idea that grammars can generate languages by recursively combining symbols. This idea is directly applied in formal language theory, a fundamental aspect of computer science. Programming languages, for instance, are built on context free grammars, making Chomsky's theories integral to compiler design. Cognitive models and artificial intelligence. Chomsky's exploration of the human mind's ability to generate language inspired early developments in artificial intelligence. While he's been critical in some AI approaches, such as statistical methods in natural language processing, his theories continue to inform debates about the limits of computational models in mimicking human cognition. Automata and machine design. The Chomsky hierarchy directly informs the design of computational machines. Finite state machines, pushdown automata, and Turing machines correspond to levels in the hierarchy, providing a theoretical foundation for hardware and software design. For example, understanding finite automata is essential in designing microcontrollers and digital circuits, while pushdown automata influence stack based computational models. Parsing and compilers. In computer architecture, compilers serve as the bridge between high-level programming languages and machine code. Chomsky's work on context-free grammars is crucial for designing syntax analyzers and parsers, which are components of compilers. Efficient parsing algorithms such as LL and LR parsers are rooted in these linguistic theories. Memory and processing. Chomsky's hierarchy also correlates with resource constraints in computational systems. For instance, finite automata represent systems with limited memory, while Turing machines model systems with potentially infinite resources. These concepts are critical in understanding the trade offs in computer architecture, particularly in designing systems optimized for speed, power, or storage. In conclusion, Noam Chomsky's influence extends far beyond linguistics, offering essential frameworks for understanding the theoretical underpinnings of computer science. His work on the Chomsky hierarchy, formal language theory, and cognitive models provides tools for designing computational systems, parsing languages, and exploring the boundaries of machine intelligence. For a computer science audience, Chomsky serves as a bridge between the abstract world of human thought and the tangible mechanisms of computation, making his contributions both timeless and profoundly relevant. Thank you for listening, if indeed you still are, and I would just like to give a special thanks to my collaborator, Cheeto, for helping me with moral support during this project.